Hi everyone, and thank you very much for your valuable time to attend this session. The main objective of this session is that you will learn how you can supercharge your network planning leveraging Crosswork Planning APIs. So what are the outcomes for you after this session? You will be able to describe Crosswork Planning key functionalities. You will learn, you will have a good idea how you can automate network planning tasks using the Crosswork Planning APIs. And also you will be able to describe and know how to use the Crosswork Planning SDK. So first off, I would like to start with a couple of poll questions. So please share with us, what tools do you use today to do network planning? Please, you can select one of the responses that I think should be displayed in the screen. So John, I think we can give maybe 15 seconds, 20 seconds. Even if you don't do network planning, or if you use a manually way to do a network planning, maybe using some Excel spreadsheets, or if you do partially automate your network planning, maybe using some scripting. So after this session, you will be very interested in adopting Crosswork Planning for doing network planning, because you will see how you can easily automate and simplify your network planning. So next, I will start doing a quick overview of what Crosswork Planning is. So I'm sure throughout yesterday and today sessions, you learned a lot about Crosswork Automation Portfolio that is very focused on automating the complete life cycle of the network operations. So recently, we introduced Crosswork Planning as part of the portfolio and placed the leading role in the planning part of the network operations life cycle. We want to build capacity where traffic will be in the foreseeable future using insights of customer traffic patterns to project where and when to acquire these capacities. We want to avoid the scenario of overbuilding capacity, which leads to inefficient resource use. And at the same time, we want to avoid failure scenarios on traffic growth, which leads to congestion and degraded customer experience. So in summary, Crosswork Planning is an AI-enabled network automation tool designed to empower network operators to simplify network planning, to optimize performance, and to achieve operational excellence with speed, accuracy, and precision. So next, what are the key features when we talk about Crosswork Planning? First, we talk about predictive AI techniques that provide a crystal ball into the future. So for example, if an NSP fails along its original path, how would it be rerouted? So Crosswork Planning will visually represent the protected and rerouted paths and whether the reroute would cause congestion or not. And then we have modeling, simulations, and forecasting tools, such as, for example, the simulation analysis that is also known as the worst case analysis tool that will simulate failure scenarios across the entire network. And using this simulation analysis tool, we can automate the failure at every circuit or node or SLRG in sequence and provide a detailed report on the impact on the network. This tool will also provide a worst case traffic view in response to those failure scenarios. And then we also have the optimization tools that will analyze traffic flows network-wide and recommend suggestions such as routing metric updates or LSP reroutes. And these tools will also provide detailed reports and visual representation on how the network will operate under these changes. So next, when we talk about network planning, one important topic is the network modeling. If we want to do a proper network planning, we need to have a proper network model and that will faithfully represent the actual network. So network modeling becomes the basis and the solid foundation for IOs. So in Crosswork Planning, we have two methods to build a network model. First one is using an active collection with a Crosswork Planning collector that will gather data directly from the network using built-in collectors that will collect different pieces of information from the network and then consolidate into an aggregated and abstracted network model that is also known as plan file. The key is to abstract the model as much as possible. For example, a network model could comprise links, nodes, LSPs, traffic demands, and their attributes. And every model is different and is made up of different elements and attributes as required to support specific use cases. And some of these attributes are collected directly from the network, while others are derived from the simulation engine. And then we have the second method, that is to build the network model offline. And for that, Crosswork Planning provides built-in tools and also provides its powerful APIs. So we need to remember Crosswork Planning network model is extensive, is extensible, is multi-vendor, and allows for both fidelity and flexibility. So that being said, I would like to show a quick demonstration with few of the common use cases using Crosswork Planning. So in this case, we access to the common web UI. From there, we can access to the network design application from where we can visualize the network model. For example, we can select the traffic demand, and Crosswork Planning will represent the routed path. So I will start with the first scenario, that is to execute a simulated single failure. So I will select one specific interface, and then we'll select to do a simulated failure. Once the failure is executed, Crosswork Planning will represent the rerouted path for the demand that I previously selected. For the second scenario, I will use the built-in capacity planning optimization tool. I will set the maximum interface utilization to 75%. And then I will select to minimize the capacity as optimization objective. Then I will set to create a new model after the tool is executed. And after execution is completed, it will produce a detailed report showing the list of circuits in the network that require some upgrade. Also, it will show the representation of the network, how it will operate after these changes, after capacity is added. So for the next scenario, I will use another built-in tool, that is the metric optimization. I will select to minimize all the interfaces utilization, and then set to produce a new network model after the execution of the tool. So after execution is completed, again, it produces a detailed report showing the recommended suggestions, in this case, the routing metrics that needs to be updated in order to optimize the interface traffic utilization. So with that, we can clearly see how Crosswork Planning can automate and simplify my network planning. But we don't need to stop there. We can go even further and supercharge our network planning using Crosswork Planning APIs. And why we need to extend network planning use cases using APIs? We may need to augment the network model. As we said, every model is different and is composed of different elements and different attributes. So using the APIs, we can access the model and add, edit, or extend new elements and new attributes. We may need also to automate the entire network planning workflow. So using the APIs, we can access to every built-in simulation tool in Crosswork Planning and customize our workflows. So then using the APIs, we can not only access to the model and to the attributes that were collected directly from the network, but we can also access to the attributes that were derived, that were generated by the simulation engine, and hence access to the simulated results and then do some post-processing based on our needs. And then, of course, we can also use the APIs to integrate Crosswork Planning with external tools. So next, some good news is that Crosswork Planning offers, for example, this optimization prediction module, also known as the OPM API, that its main characteristic is that it is it uses a high-level Pythonic syntax. So for example, in the pictures below, we can see to the left side how an operator can add manually an LSP using through the Crosswork Planning API. So he will need to insert the new LSP and set the corresponding attributes. But what if we need to add multiple LSPs, 100 or 1,000 of LSPs? We will need to automate this task, right? So to do so, we can use Crosswork Planning APIs. So in the right side, you can see a code snippet of a Python script where we are using our OPM APIs. So the first important thing is that we need to import the OPM library. So in this case, we use the com.cisco.way.opm. And from the same line, we can also import the openPlan function. So this openPlan function we will use later in order to read the plan file and then set the content into a variable, for example, network. And from that point, we can start accessing the different objects using the dot notation and with any other Python library. So for example, if we want to access the model object, we can use network.model. And then if we want to access the LSPs object, we can use model.lsps. And then if we want to add a new entry into the LSPs object, we can use the append function, similar as with any other Python standard list. So in that case, we will need to pass the respective attributes of the new LSP using the append function. So this looks very simple, very easy to use, very high-level Pythonic, right? And so then another characteristic of this OPM API is that it is a design RPC API wrapper. And I will explain what this means in next slide. So next, we have also the Crosswork Planning Design API that is also known as the Design RPC API. So what are the main characteristics of this API? It requires a client-server connection. It uses an RPC mechanism. Supported languages are Java and Python. And the main concepts that we need to take into account when we use this API to create our scripts is that we will use objects, attributes, and managers. So in the right side, we have a snippet code of a Python script using this RPC API. The first main important step that we need to take into account is that we need to import the design library, that in this case is com.cisco.way.design. Then a good practice is that we also import the respective classes and data types that we will use with this API in my Python script. Next, second important point is that we need to establish the connection, and we do so using the service connection manager. Then once the connection is already established, we can access and read the plan file using the plan manager. So after this point, we can start accessing the different objects by calling the respective managers. So for example, if I want to access the traffic level object, I will need to call the traffic level manager. Or if I want to access the QA object, I will need to call the QA manager, and so on. So then in the snippet below, we have a function that will do the insert of the LSPs into the model. So what we need to do is to create an LSP record for every new LSP that we will insert. And this LSP record is a class structure, and it is composed of all the attributes that belong to the LSP object. So at some point, we will need to access to the LSP's object, and we do so by calling the LSP manager. And if we want to enter some specific traffic into my new LSP, I will need to call the measure traffic manager, and later use that measure traffic manager to access the LSP measure traffic, and so on. So this is like a hierarchical level that we need to call the respective managers in order to access the corresponding objects and attributes. So at first sight, you may think that this is a bit more complex than the OPM API. And of course, we require more lines if we compare lines of code if we compare to the OPM APIs for the same or similar operation, right? But one main important point when we talk about the design API is that this is the very native Crosswork Planning API. So this means that with this API, we can access to every attribute in the model, either if it is a measure or derived or user-defined. It can access to every table in the reports and also to every built-in simulation tool in Crosswork Planning. And this is something that is not necessarily available with the OPM API because the OPM is actually a wrapper of this API. But the good news is that both APIs can interact with each other. So in the OPM API, we have some specific functions in order to call the corresponding RPC API, or we can simply import the both libraries into the same Python script and then combine the usage of both. So then we have the Crosswork Planning Job Manager. The Job Manager is a page in the Crosswork Planning UI that will let us visualize the tools and initializers that were scheduled to run as background jobs. In these background jobs, we can set priority, schedule time, or we can cancel them before they enter into the running state. So then one important point is that this job manager page will also provide options to execute jobs using the CLI binary tools that is not in the scope of this session, and also using the custom scripts, which is the main focus of this session. So next, I will show an example of a demonstration using the OPM API for a very basic use case that is assigning sites to nodes. So in this case, we can see in the plot how the nodes are grouped, and then we can verify the sites table that it is empty. Then we can check the format of the node names, and we can see that the first part of the name represents the function of the router in the network, and second part represents the acronym of the city where it belongs. So we can go ahead and manually insert a site via the UI. We can set the name using the second part of the name, in this case ATL, and set manually the geographic location using the city name, in this case Atlanta. Once we click Save, the site is created. We can see in the plot, but it initially will have 0 nodes assigned to it. So we can go into the nodes table and select all the nodes that belong to this ATL Atlanta site, edit them, and assign the corresponding site to them. So once we click Save, we can see the site is updated and it is showing the 3 nodes belong to it. Next, Crosswork Planning offers one built-in tool to do similar operation, but in an automated way. So we can select all nodes, we can define some rules, for example, set what delimiter we will use in the node name, in this case, the dot, and we can select which part of the name we want to select and use as the site name, or we can use maybe some regex expressions. But we can also automate these actions using our Crosswork Planning APIs. For example, the OPM API, we need to import the library, call the OPM open plan function. Then we read the CLI arguments, our input plan file, output plan file. And then using the open plan function, we will read our input plan file and set into the network variable. Then we start using the dot notation to access the different objects, model, and nodes. Then we can use a for loop in order to read every node in our nodes object, and then verify if the node belongs to a site or not. And if it doesn't belong to a site, then we can read the node name, split using the dot delimiter, and then select the second part of the node to use as the site name. And then with that single line, we can create a site and assign the corresponding node into the site. And finally, write the updated model into my output plan file. So then let's go to the Crosswork Planning UI and the job manager page. From here, we can select to add a new job using a script. We can either upload a new script or use an existing script. In this case, I previously uploaded my script. So next, we need to select the input files. In this case, I will select my input plan file, that is the unprocessed lab.plm. And next, we need to set the script command. In this case, we need to call the script and then pass the corresponding CLI arguments, the input plan file and my output plan file name, that will be plansites.plm. So then click Next. We can select to execute the job now or in a background scheduled job, and then set the priority. And once I click Submit, the job will be created. We can click Refresh, and then it will be in running state. And then once it is completed, it will produce an output file containing my output plan file. So next step is that I need to import my output plan file. Once it is imported, I can click on it, and then it will be loaded into the network design page. So here we can verify that all the sites are already created, nodes are grouped into sites, my site table is populated, and then we can combine with another built-in tool, for example, the assign locations to site, that will read all the names of the site and will do a best match based on the name to assign the corresponding geographic location. So we can see now geographic locations are already added, and if we change to the geographic view, we can visualize the position of every site in the map. So then I have another example, and this time it's a demonstration using the RPC API, and my use case will be that I will insert demands in bulk. So here I have my network model, which already has the demands table populated. All my demands are functional. If I select one of them, we can see Crosswork Planning represent the routed path for each. So next, we have the option to insert new demands either individually or using demand mesh. If I use demand mesh, I will need to pass the list of source and destination nodes. And later, I would need to use the demand deduction in order to assign the corresponding demand traffic. So for this example, I will select to add a new demand individually. So I need to set the mandatory parameters as the demand name. And then I will select the source node, that in this case will be node 4. And the destination node, that in this case will be node 5. So then I can select to add some demand traffic, in this case 6 megs. So once I click Save, the demand will be created. And then we can verify in the demands table the new demand is added. We can open the name column and verify the corresponding name that we set for this specific demand. So it is totally functional. We can see the links and color links are updated because traffic increased because I added my new demand traffic. So we can automate all these operations also through the APIs. So for example, I have this specific CSV containing 4 demands, right? So I have my Python script that will use my RPC API. So I need to import my design library. So then I will import also the classes and data types that I will use in this script. And next, let's focus on the main function. So in this main function, I will start reading my input arguments, in this case, input plan file, output plan file name, and then the CSV file that will contain my demands. So first main step is that we need to establish the connection, right, to the design API service. After connection is established, we can read the plan file using the plan manager. And then in this case, I will read every entry in my CSV file that will contain every demand attributes, and I will create a dictionary for each demand, and then we'll call the update demands function. So in this update demands function, I will basically access the demand object by using the demand manager. And then I will access the demand traffic object by using the demand traffic manager. So then I need to create a new demand record for every new demand. The demand record is a class structure containing all the attributes of the demand object. Next, I use the demand object in order to insert the new demand records. And we do the same for the traffic using the demand traffic manager. So after all this process is completed for all the demands in the CSV file, so next step is that I will write the updated model into my output plan file. And finally, we close the connection to the design API service. So now let's go back to the Crosswork Planning UI in the job manager page. So I will select to add a new job using a script. I will select my script that is already uploaded. And we'll select next, and next I need to select my input files. In this case, the input plan file, that is the srset.pln. And also I will select my CSV file containing my demands. So next I need to set the script command that is calling the script and also passing the corresponding arguments, input plan file, output plan file, and then the CSV file containing the demands. So next, I will execute the job now and set the corresponding priority. And finally, once I click submit, the job is created. So when I click refresh, we can see it is in running state. And once completed, it will produce the output plan file. So next step is to import the output plan file and then load into the network design application in order to visualize the results. So once I open the plan file, then I can go to the demands table in order to verify the new demands. So we can see in the bottom, we have our 4 new demands that were inserted via APIs, and they are all functional. If we select them, we can see Crosswork Planning will represent the corresponding routed path for each. So next, I would like to show to you another example that is an integration demonstration between CNC and Crosswork Planning. So as you may know, CNC collects the topology in real time, and it will also have traffic statistics. So we can take advantage of that and take a snapshot of that topology and then export it and then import it into Crosswork Planning in order to use our simulation tools. So in this case, we have the CNC UI where we know that topology is collected in real time and traffic statistics are collected in a cadence basis. And then in the right side, we have the traffic engineering panel where we can see that we have, for example, in this case, 32 SRMPLS policies. And then we have also 9 SRV6 policies and also 2 RSVPT tunnels. So in total, we have 43 LSPs in this network model. CNC offers some RESTconf APIs in order to do the export of this network model into the plan file format. So next, I have my Python script using the RPC API and other standard Python libraries. So let's focus on the main function. The objective of this function is that it will call other functions that will do the export of the network model from CNC, and also will do some post-processing of the model using a specific template file. So I will start reading my input arguments, like the input plan file, output plan file will provide the CNC details, and also the template file name. So then I need to start, of course, opening the connection to the service design API. And then I will set the corresponding authentication with the CNC. And then I will call to my getCOE function that will do the export of the network model. So once the network model is exported, then I will read the plan file using the plan manager. And next, I will start the post-processing of the model. So for example, if copy template is set to true, then I will call the copy from template function that will basically get all the geographic location from the template file and set into my model. And then if copy inventory is set to true, I will also call the copy from inventory function in order to copy from the layout file, from the template file, some basic inventory details like vendor, model, and OS. And then if create demands is set to true, then I will use via API, I will call the built-in simulation tools like demand mesh and demand deduction in order to create a full demand matrix and also assign the corresponding demand traffic. So once this is all done, next step is to write into the output plan file the updated model, and finally close the connection with the design API service. So next, let's go back to our Crosswork Planning UI in the job manager page. So I will add a new job, then select the corresponding script. And next, select my input files. In this case, I will select my input plan file. That will be an empty plan file. And then select the template file that I will use for the post-processing of the model. So next, I set the command and add the job. Then I check that the job is running once I click refresh. And once completed, it will produce the output plan file. So next, we can go ahead and import the output plan file, and then we will visualize that it has exactly the same topology with the geographic location as we had in CNC. We can verify in the nodes table the 8 nodes were imported, and we have some basic inventory information. And then if we check the LSPs table, we can see that we have the 43 LSPs that were imported, including the SRv6 policy, RCVPT tunnels, and also SRv4 policies. And then in the demands table, it is already populated and all demands are functional. If I select one of them, we can see Crosswork Planning will represent the routed path for each. So now, so far, we have seen how we can build the scripts using the design and OPM APIs and execute them locally in the Crosswork Planning VM through the job manager page. But what if I require to execute, to automate some tasks and execute a script remotely? So for that, Crosswork Planning offers the Crosswork Planning SDK. The SDK is a package containing the design and OPM API libraries, and will allow the user to write and execute scripts using design and OPM API outside of the Crosswork Planning VM in a Linux user machine that will have some specific Python requirements, will connect to the design API service that is running locally in the Crosswork Planning VM. And for communication between server and clients, we will use a TLS secure protocol, and also we will use SSL certificates. So next, I would like to show another example of a demonstration using the SDK client. And for this use case, I will also execute the inbuilt simulation analysis tool using the APIs. So in this case, I will use my US1 sample plan file that already contains a sample network model, and I will show you how you can execute the simulation analysis tool from the UI. The objective of this simulation analysis tool is that it will execute automated failures across the entire network based on the failure sets that I select. In this case, I will select nodes and circuits. So next, I will select to execute the tool now. And once the execution is completed, it will provide a detailed report. In this report, we can see in the summary tab, it provides the summary of the QoS violations and their failure conditions. And then in the max utilization tab, it will provide the percentage of failure in this network, in this case, 23%, that would cause the maximum utilization to exceed 100%. So then I close the report and go back to the model, and we can see that the tool also created a worst case traffic view showing the maximum utilization, worst case utilization for every interface in the model in response to the failures that were executed. Then in the interfaces table, it will also populate the worst case column. So for example, we can sort from highest to lower the worst case utilization, and we can find out what would be the maximum interface utilization in this network, that in this case, it is 125%. Then we can open also the worst case traffic and do some similar action. We can sort from highest to lower. And then we can find out what would be the maximum worst case interface traffic in this network, that in this case, it is 3 gigs. So we can automate all these steps using APIs with this Python script using RPC API. So I will focus in the main function. Again, I will read my input arguments, like the input plan file, the failure types that I will pass to my simulation analysis tool, and the cross-site planning details, like IP address, port, and protocol that is fixed to SSL. So next, I need to open the connection with the design API service and then read the plan file using the plan manager. Then I need to access the tool object using the tool manager, and then we'll create a simulation analysis using the tool manager. So next, I need to set the options that I will pass to my simulation analysis tool, in this case, the failure types that I receive via CLI argument. And next, I will need to execute my simulation analysis tool. So next, I will call two functions. In this case, the first one is to get the maximum interface worst case utilization, and second one is to get the maximum interface worst case traffic. And finally, we'll close the connection. So next, I will show you my SDK client. In this case, this is already prepared with all the prerequisites of the Python libraries, and the SSL certificates are installed. So in this case, I have a specific directory structure where in the scripts, I have all my Python scripts, and in the plan files, I will have my input and output plan files. So I will call my script using the Python command, and then I will pass the corresponding arguments, the input plan file, the IP address for the cross-site planning VM, the port where the design API service is running, and the failure types that I will pass to my simulation analysis tool, in this case, the nodes and circuits. So once I execute this script, it will run in the background the simulation analysis tool and provide exactly the information that I am looking for. In this case, the maximum worst case interface utilization, that is 125%, and the maximum worst case interface traffic, that is 3 gigs in this network. So this way we can see how we can remotely connect to the design API service and also remotely execute the scripts in a secure way using TLS protocol. And then also we can access to the simulated results and do some post-processing in order to get the specific information that I am looking for. So with that, I completed all the demonstrations for today. So I would like just to share some key takeaways. As you could see, you can simplify and automate your network design, planning, and optimization using cross-site planning. But you cannot stop there. You can go further. You can supercharge your network planning using cross-site planning APIs. And using cross-site planning API for customization is really easy with the Pythonic APIs. So one call to action, remember tomorrow we will have a hands-on lab session for introduction to cross-site planning, where we will explore some basic use cases. And also we will have few scenarios using APIs. And then I wanted to share these reference links with a cross-site planning information center. Also in T-Cloud, we have an available lab that is the cross-site planning 7.0 design. And I'm sharing also the link for the cross-site planning DevNet Center. This is currently under QA review, but will be available very soon. And I'm also sharing a GitHub repository, this is public, where you can find some sample scripts, including the ones that I showed in this session and a few others. With that, I completed my presentation. So thank you very much. And back to you, John.
Thank you, Julia. Nice job. We only have 2 minutes before we go on break. First of all, I figured out how to look at the survey results. So let me just tell you guys what the responses were. So the first one was, what tools do you use to do network planning? Interestingly, most of the folks, almost 43%, use Excel spreadsheets.
Okay.
15% do no network planning. 15% use scripting, and 30% actually do use in-house or vendor automation products. So
this is really interesting.
That's pretty interesting that 43% are using Excel spreadsheets. So over 50% are basically doing it or not doing it with on paper. And then the other survey, how familiar are you with Cisco WAN automation engine or Crosswork Planning? And 75% never heard of them,
Okay.
which is which is uh, which is a big opportunity, I think, for both the
Yes,
customer and for
I think it
Cisco.
is the right audience because you will be interested in adopting some automation tool for your network planning.
Yeah, and the interesting thing about when Javier spoke about AI and getting into proactive use cases, um, the real nirvana is where your AI tools can begin to move traffic across different paths, so you can basically optimize your bandwidth and provide the best user experience. And these tools are really the back end systems that the AI will use to kind of figure out the best paths to take for things like bandwidth on demand and congestion management. So it's important that folks begin to really learn about these tools, because this is how it's done, really, to really make sure that bandwidth is used as efficient as possible. The last uh, poll, on a scale of 1 to 5, how confident you are in programming in Python. uh, 33% not confident at all, 33% a little confident, 17 fairly confident, and 15 extremely confident. So the majority of the audience, um, aren't that confident with Python tools. And I just want to highlight that you showed Python and APIs, since this is a developer conference, but certainly there are front end UIs and other menu driven tools for the product, that weren't really shown or highlighted as much. So you're not you don't have to know Python to use these tools, but certainly if you're a developer, you can certainly maximize it.